I'm Gill. I am a software architect, which is how they call software developers after 30 years of experience. And I work at Applitools. We do visual testing, which I maybe talk about in the. My speech is actually how to do browser testing without a browser. No Phantom, no WebKit, no Chrome headless, no nothing. How can we run all those tests, but browser tests that use DOM and everything without a browser? Come and see. Hello, everybody. Yep, that's me. My name is Gill. You've heard the whole introduction, so no need to do it again. Just making sure you understand it's the same person that was talking about a second ago. Just a little bit about me. As I said, I go all the way back to the 80s, from DOS, if somebody of you remember that. I am a developer, was a developer, and always will be a developer, even though they call me an architect today. While I am a developer, testing code is a passion of mine. I test everything. Every little line of code I write, I test everything. I do test it after I write it, not before, but I still test it. I'm currently an evangelist and an architect at Applitools. We do visual testing tools. In the previous talk, there was somebody who asked about screenshots. Is she still here? I will give you that answer. And another guy was talking about how slow those clicks are. I think it's you. No? Okay. So I will answer that. Actually, that's the main thing I'm going to talk about. How to make those browser automation tools much faster, like 10 times faster, even more. Okay. You know, Roy Osharov in his keynote talked about, the tools, all the DevOps tools, they're easy. The problem is the culture and the people and all that. I can relate to that. People are a bit of a problem, especially to us developers who are somewhat autistic in that area. But hey, come on, tools are difficult. I want to talk about tools today. I want to show code. I want to show people how to write those browser automation tools, and we will show a lot of code. It will be in JavaScript. If you don't know JavaScript, that's fine. You need to get the feeling of it, not so much the little details of it, but it will be JavaScript, and we will go deep. So feel free to fall asleep if it's, but I will try to keep you on edge because the lunch, Okay, so let's write an app because we need to test something. So let's write an app, and the app is an amazing app. It's a counter app where if you click on the plus, do you have a more complex example? That was also a question. Yes, I do. When I used to work at Wix, we wrote a whole thing, and we used this technique, so don't worry. But I will be doing everything on this app. You click plus, it increments the counter. You click minus, it decrements the counter. And there's a bug. If you click minus, after 0, it will go -1, -2, etc., etc. So please, it's not a bug. It's a feature. So the HTML is pretty easy. It's just a div with an ID root, which we will hang the application inside. And all the code will be done in JavaScript, in front-end JavaScript. So let's look at that. First of all, we're just putting in the HTML using JavaScript. It's a link for the minus, a link for the plus, and a div for the value, which will increment 0, 1, 2, and vice versa. We will get the element because we will need to change the value of the element, the text inside the element. So we're using document.getElement by ID. And we add a listener to the increment and decrement elements, or the click. So when the click happens, this is what happens. We take the text content, we parse it into an integer, we subtract or increment by 1, and we put it back in the value content. That's the beauty of typeless languages. You can put an integer into a string, and it somehow just works. Okay, that's the app, and it works. I tested it. Both manually and we'll see the test in a second. Let's test the app. Currently, there's only one way to test the app. There are lots of frameworks that do it, but they're all the same. You run Selenium or Casper or Puppeteer. What that does is it brings up a browser. In this case, Chrome, but it could be Firefox, whatever, IE, etc. You bring up a real browser that eats up lots and lots and lots of memory. And then you write the test. In this case, it's Mocha. Mocha is my favorite testing framework. It doesn't really matter which. And you say get, driver.get, so the browser navigates to this page. This page is on the disk, so it's a file URL, and it navigates to that HTML that we saw earlier. And now we find the element, the increment element, and we click on it. So we're sending the browser commands and queries. Please find this element, please click on it, etc., 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 and the browser is acting on that. And in the end, we find the element for the counter value and expect the value to be 1 because we clicked on the increment. That's a test, and it works, okay? It's like there's 20% of it missing, just preamble and postamble, but basically that is the test. That is a Selenium WebDriver test. Really simple to write. Obviously, when you have hundreds of these, it gets more complicated, but in essence, that is the essence of browser tests. So they run under Node. Lots of you use probably Java or C#, that's fine. Python to write it, but they're basically the same. This technique that I will be showing works only under Node, and we will explain why later. It starts a browser and it queries it, as we spoke. Now I want to go back. I want to zoom a little back and talk about the pyramid of testing, which is amazing. Every person I talk to has a different pyramid. They all have a pyramid of testing, and it's always, but what is inside the pyramid is anybody's guess. I will talk about unit tests. In the context of front-end application, unit tests check one component of the application. Integration tests check many components of the application. And end-to-end tests do browser automation. That is where browser automation lives. The pros of browser automation is it tests the real thing. That's why it's called an end-to-end. And it's relatively easy to implement. We saw like 10 lines of code and you're done. No, not difficult, especially in JavaScript. The problems of browser automation is they're incredibly slow. They are very, very slow. Each click takes time, and then you have to wait for the page to render and all that. Really, really bad. They're flaky because you have to wait. Because it's a real browser, sometimes the browser stops, stalls. Sometimes the network doesn't work. Sometimes cosmic rays. I don't know. Just things don't work in these kinds of tests. Nobody knows why. And they're flaky. And they consume lots of memory, which is not a problem unless you're doing CI, unless you're doing a build system, and you have lots of these running on one host or many hosts. Memory is money. More hosts to run your tests. So the less memory it is, the better you are. And these consume a lot because you're running a browser. Chrome, for goodness sake. So how do we write tests that are as fast as unit tests, run in memory under Node, and yet test the whole app? And the answer is, we run the application code, not the test code, the application code in Node.js. This is the dream, and we'll see how to implement the dream. If we could, before every test, just require the code of the application. This require imports the code of the application, not test code, not a package that helps you test the code, but the application itself. Remember, it's this code. If we could just require it under Node, have it do its thing, and when you test, just click on the increment button. You have the document in your hand. If we could have the document, if it's running under Node, we could have the document in our hand. Just click on it. And check the value, again using document.getElementById, and check the value. But we can't. Why can't we? Very easy. There's no document in Node. Node is not a browser. Node is a server platform. Node is just a regular programming language. There's no document, there's no window, there's no navigator. So if you require that code and that code accesses document, oops, sorry. Oh my God. It requires, requires document, it won't work. It will say undefined and all that JavaScript stuff. But, there we go. There's a solution. And it's a really, really, really powerful solution. It's called JSDOM. Anybody heard of JSDOM? Nice, nice, nice. Let's look at how this works in JSDOM. Let's run the application in Node using JSDOM. So we start with importing JSDOM. It's just a regular library. You just npm install JSDOM if you're under Node. Just install it and you have that package. It's a regular package, pure JavaScript. And you call the JSDOM.jsdom and you give it the HTML. In this case, it's just a div with a hello world. This is a sample app. We'll show how counter works later. What you get back, incredibly enough, is a document. The document, the DOM. So it has all those DOM stuff that we're used to, get element by ID, inner HTML, elements, all that thing. It's all running under Node, simulated as if it was a browser. So you can go to the get element by ID, go to the root, get the text content, and console log it, and it will print hello world. We saw the HTML above. That's it. Amazingly enough, JSDOM is so good, written by really brilliant people, I salute them, that all the applications I could throw at it, full-blown web applications, all of them just worked under Node. So let's see how this works. How do we use this? Oh, sorry. So how do we use this for testing? Again, we go in the before, which is before all the tests. We set the global. Global in Node is a variable, which if you set a variable in it, global.document, document will now be available everywhere as a global variable. So you set global.document, but then you have a global variable called document. So if I do global.document, now everybody can see a document variable that they can just use. So they can just require, we can just require the app. Remember the app? The app just uses document. It goes and does get element by ID, gets the element root, inserts inner HTML with that, then adds event listeners. All these things will work under the new document that we created under JSDOM. Incredibly enough. I'm still amazed. Sorry about the emotion. Okay. And now we can just, the application has run, this code has run, and we can just test it. Get element by ID, we can use the same document as them, as the application. Get element by ID, get the ink, click on the ink. Click is a method of an HTML element on the DOM. Get element the counter value and expect the value to equal 1. Is there a network here? No. Are we running a browser? No. It's all in memory. We're talking 10 times, probably more, faster than a regular browser automation tests. Unfortunately, modern JavaScript applications are much more complicated than this. Nobody writes like this. I wrote like this in the 90s and in the aughts. Nobody writes like this anymore, jQuery and changing the inner HTML, etc., etc. How do they write? This is how they write. Most places in modern JavaScript use either Angular or React. I'm a huge React fan, so I will be using React, but the same thing applies to modern Angular, not Angular version 1, but Angular version 2 and later. But the same thing. This is how code looks like today, and let's go over it a little bit. Even if you don't fully understand it, it's okay. We need to understand not the details, but the inner. Let's see what's changed. First of all, application code is using require. Okay. Require, just like Node. Node invented the whole idea of packages and NPM and require, but now people are using it in their application code. React itself is a library that you can require and use it as we saw. Oh, sorry. Another thing, can you look? You see that class? Class is ES6. It's the newest version of JavaScript. It's actually already like 3 or 4 years old, 3 years old, 2 years old. That's it. Most browsers today support it, but not all of them. So this code won't run. We'll talk about that later. It uses ES6, and React and Angular use ES6 very, very heavily, not just like in a light mode. And look at this. This is really strange. This is JavaScript code, and yet it has angle brackets just like HTML. This is called JSX. It's something that React invented, but lots of people use it outside React. Vue.js uses it, and other frameworks use it. It's a really cool thing. The whole idea is that these angle brackets just translate into regular JavaScript objects. So nothing really interesting. It's just a nicer way of writing regular JavaScript objects. Okay. So this is, oh, and of course, we render everything in the client using React. Once you rendered it, the whole thing just works. If you look here, you can see that the on-click of the decrement does a set state. It sets the state of the counter to -1, and then it re-renders. The whole thing just works as if magic. But does this run under the browser? This code? The answer is, let's check. Does require work in the browser? If we script source this file, would require work? Anybody know? Yes? Who thinks yes? Who thinks no? Okay. The others don't know, which is fine. This is why I'm here. The answer is no. The browser does not recognize require. It doesn't have any package management, no imports. They're going there. Like in 2 years, we'll probably see that very heavily, but it's not currently supported. What about React? Does React run under the browser? Well, yeah, obviously React was written to run under the browser, so no problem here. Does ES6 work on the browser? And the answer is mostly, but mostly doesn't cut it. So some browsers don't run ES6, they still run the old ES5 version of JavaScript. JSX? No, most definitely not. It's not even on the plan. So JSX does not run under the browser. So how? How does this code that developers write run under the browser? And the answer is very simple. It doesn't. What runs, if you look at a modern code base, you will see lots and lots and lots of files. Everybody requiring everybody else, like in a tree-like form. Somebody needs to do 2 things. One, compile the ES6 code, the new version of JavaScript code, to the old version of JavaScript code. Convert it. And 2, take all those files and bundle them into one big file. And that is what Webpack and Babel, as you can see here, do. Babel transpiles from ES6 to ES5, and Webpack bundles them, and they do it with hundreds and hundreds of configuration files that nobody can understand. But everybody copies and pastes, so it's fine, it works. And I want to go back to it because, interestingly enough, every time a developer changes one file in this file tree, the whole build process needs to run again. Remember that, we'll talk about that a little bit later. Every change needs a rebuild again and again and again. So, okay, so we saw the code. We saw the code, how it works under the browser using Webpack, Babel, transpiling, and it finally works. This is how modern JavaScript applications work. But how does this work under Node.js? And I want to talk about a term that has become very trendy in the last 2 years. It's called isomorphic code. Isomorphic code is a fancy name for code that runs both under Node and under the browser. The nice thing about Node.js, and as testers, I really want you to consider using JavaScript, using Node.js as your test automation tool, because it's the same language that the front-end developers work with. And you mostly interact with front-end developers, and you mostly use front-end developer code. So having your test automation tool not use Java or Python or C#, but rather using JavaScript is for me, an advantage. If you're using this way, then you have to use Node, and I'll explain in a second. So yeah, and JavaScript is becoming a really nice language. So don't hesitate. It was really horrible like 10 years ago, 5 years ago, but now it's really nice. So isomorphic code is code that runs both under Node and under the browser. What does that mean? Let's separate two types of code because it can become confusing in this setup of automation. We have test code and we have what we call production code or application code. The test code is the code that tests the application. The application code is the application itself. We call it a lot of times production code. Why is this confusing? Because when we're doing Node.js, they're both running together at the same time. They're both using the same language. When you're doing Java automation code, nobody gets confused. But when you're doing JavaScript automation, it's confusing. So we want the test code to run under Node, because we want the test to run under Node. But the production code needs to work both within the browser and under Node. And that production code needs to be isomorphic, meaning it runs both under the browser and under Node. So that's the meaning of isomorphic code. You can hear about it, some people call it universal applications or universal code. Same. So, does our production code, which we saw earlier, does it run under Node? Let's check. Require. Does require run under Node? Thank you. That was very pleasant. Yes, definitely. Why? Because it was invented there. Require first worked under, it's called CommonJS packaging. It first worked under Node, and then the front-end people imported it into their system. So, require works. Does React work under Node? Amazingly enough, it does. It's the first major framework. I can't say it's the first framework because probably it's not, but it's the first major framework whose code was built to also run under Node. And why? Because React also knows how to do server-side rendering. So it can render, it can show the application HTML in the browser, but it can also show the application code under Node. Turn the application code into a string which is returned by the server to the client. So it does server-side rendering, so all of its code was built to work under the server. And amazingly enough, even the client code, if you give it a document, also works in the server. Does ES6 run under Node? Yes. Node 8, the current version that is running, even works with ES8, so what is called ES 2017. So it's far advanced from what is possible in browser land. No problem there. It's no need for transpilation, compilation, anything. It just works. Does JSX run under Node? Nope. As we said, JSX, there's no plans to incorporate it into JavaScript. It's not built for JavaScript. It's a Facebook thing. React is a Facebook framework. Nobody is thinking of porting it to Node or to JavaScript. So what do? We use a library called Babel Register. Babel Register is a library which has a hook. It hooks into all the imports. And all the imports it uses go, if it has the correct Babel RC file, all the imports go through Babel and are transpiled according to the information here. So all that JSX will be automatically, I would say, compiled into regular JavaScript using Babel transparently. So if I just do -- require Babel register, I get JSX for free and I don't need to work for it. So let's run this application, this React application, this modern JavaScript application. Let's run it under Node. Okay. So instead of doing document equals, we do global.document because we need the document to be a global variable for React, for the application purposes. And we also need a window and a navigator, so this is how we get the window and the navigator in. Don't ask me why, I have no idea. It just didn't work without it. We get the window and the navigator also as globals. So now we have a really good simulation of the browser. Now we require React and we run the application. We require the counter and we render it. That's it. Now we have the counter application working under JSDOM, under the simulation of DOM. And we can even use jQuery. Incredibly enough, jQuery works under JSDOM. So we initialize it like this, and we can just check the value of counter value using jQuery selectors. How does this work in test? Same. We put all that code, initialization code, in the before of the test, and then we can use jQuery to not horrible other things. Just expect the link to have length 2. So we want 2 links, and expect the first link to equal minus, because we haven't clicked on anything. So that's the first thing we check. And the second thing we check is we click. Again, we just trigger the event using jQuery, regular, normal jQuery, and we expect the counter value to have incremented to 1. Okay. That's it. I mean, it's a long story, but in the end, what we get is a full test of a modern JavaScript application using Node.js. We have regular DOM rendering. We have JSDOM, jQuery, DOM events, the whole thing just working under DOM. It runs in milliseconds. We had it's a previous company of mine, we had hundreds of milliseconds, in like 10, 20 seconds, we had hundreds of these full-blown end-to-end tests running, hundreds of them in seconds. No need to run a server to make the browser work. No need to run a browser to consume all that memory and make everything flaky. You can debug. You don't need to debug with Chrome Developer Tools. You just debug with any regular Node debugger. No build step. That's easy. When we worked on the application, we had to rebuild everything on each change. Here we just run the test again, and it works. And if you have XML HTTP requests, if you're doing API calls from the application, you can mock them. There are really wonderful mocking libraries for HTTP requests in Node. I use Knock. It's a mocking library for HTTP, and it just works. So you can mock your HTTP requests and test the application using a mock server. Very easy to implement. So perfect. And you know, it sounds too good to be true. And when I say it, I'm like not believing myself. But I've seen it work. You know, all our tests work that way. So why do we need browser tests anymore? That's the big question. If it is true, why do we need browser tests? And the answer is, there's always an answer. You always need to do full-blown browser tests. First of all, JSDOM is not a complete solution. Brilliant people, but they didn't implement service workers. They didn't implement, I think, web workers. Frames don't work as they should. So some things just don't work using this thing. There are slight incompatibilities. Just like think of JSDOM as just another browser. So there may be slight. Well, actually, we haven't encountered them, but there probably are incompatibilities somewhere. So you have to check your application against a regular browser, but you have to do it only in the happy path. You know, just a few tests, just to make sure that the application runs, and run all your tests under Node. And that was the question about screenshots. You can't do visual testing. Visual testing means checking how your application looks, not just behaves. It means taking screenshots and verifying that those screenshots work. That is not possible yet under JSDOM. The whole thing of visual testing is really trending. Lots of vendors, among them Applet tools. You should try them out. They can even make functional browser tests even more reliable, because basically they check the whole test, the whole page in one screenshot. For me, I would run most end-to-end tests, most browser tests under JSDOM, and do the visual testing and the happy path testing of functional testing using a really, really, really good browser. Okay, now the way this talk was created was like a year and a half ago. I was asked to give a lightning talk at a React conference. And I built, and I said, yeah, lightning talks are really nice, like 5 minutes, but I want to do them even nicer. So I created a poem. I created a poem for the lightning talk. And like 4 days before the conference started, they called me and said, would you mind upgrading your lightning talk to a full-blown talk? And I said, yeah, sure, yeah, even nicer. But I already had the poem and the slides and everything, and it was too good to waste. So I think I'm going to just summarize what I said by reciting a poem, which I wrote. So, it was a long time ago. The pyramid of testing was the light of our soul. We had lots of tests, mostly unit, of course, and a small set of end-to-end tests, which we did without remorse. But what about integration tests, my friend? Should they be like the unit, or rather the end-to-ends? Should they clickety-click the buttons in the UI, like in the end-to-end suits, or like the units, call some methods and check the results? And I'm sorry if some of these rhymes appear a bit obtuse. For if they are like the end-to-ends, they run very slowly. And if they are like the units, then they don't check it all. Oh, if only we could test the whole code through the UI, yet run them as fast as can be. Halevai. Halevai is Hebrew for I wish. I need all the languages I can for these rhymes to work. Capish? So what do we want now? We want tests that check the whole code, but somehow run as fast as the unit tests, damn it. Fast and complete, that's the requirement. The crux of the matter is the browser. The infernal thing can't go any faster. It's so slow, but it's the only thing that can run JavaScript. It can't be skipped. But wait a bit. What if the browser can't be skipped? 5 years ago, I would have said, no, it can't be skipped, no. But today, we now have for Node runs JavaScript pretty good, for it has the V8 engine under the hood. It can run as fast as the browser, and actually much faster, because it doesn't carry so much baggage, and that's a huge advantage. But part of that baggage we need. Oh yes, we need it indeed. Because without that baggage, our tests can do clickety-click on the buttons and can't be like those end-to-end tests. And what is that baggage? It's the DOM, the browser's jewel. And no, not Dom Perignon, you fool. Without the DOM, our integration tests amount to nothing. End of discussion. The DOM is the code that reads the HTML and creates the element hierarchy, pal. Those elements that contain the app's content, those elements, they respond to a user's event. But what if? What if? And it's a pretty big if. The DOM we could rewrite. And if we do it right, we could run our DOM code under, what was that engine? Node? If we have a DOM under Node, damn it, why, the sky could be the limit. We could test all our code, the clicks and the renders, under Node. But wait, this dream may yet come true, for it seems that NPM has come to the rescue. For there is a package, it is true, called JSDOM, color me blue. And it's a complete simulation, lacking in almost nothing, of the browser's DOM support. It's actually a pretty good port. And the code looks something like this. And if I'm not amiss, it can even run jQuery vanilla and use it to query our DOM. Hallelujah. So now to this code, let's add some oomph. And since we are not in a React conf, we'll write the application we want to test in a React, of course. It's the best. And now that we have our application we can test by just rendering it into our DOM, And it's time to confess that it's as easy as that, as nice as tapioca, but only after we wrap it in Mocha. Now let's run it with Mocha. Why? To check the application code, duh. Oh, the test has failed. No matter. This fix has it nailed. And no matter those, and we run it again. We're green, so let us say amen. Did you see what just happened there? We just fixed it and ran without having built it. No build step, no Webpack, no Browserify Babel, even though our code used require and ES6, you can tell. And yet it ran just like that. As fast as can be. Milliseconds for a test. That's a miracle. I bet that you can see. But how does it work? That's the beauty of Node version 6. It's the first node that fully understands ES6. So now we can just examine the code and adjust and have no build steps to run all the tests. And they are as fast, 10 times faster than in the browser. We can run hundreds of them before you can say wowzer. And the friction is gone. We can fix them ASAP without that freaking build that transpile and packs. And as a nice plus, we adjusted and moved all our unit tests to run under Node, not the browser. And if our code uses ES6 and requires, so what? We support that. And our time to run unit tests was also cut. And now just our end-to-end tests run in the browser. And they're a pain in the butt, as they should be. But the mass of our tests run under Node and runs gazillion quickly. So next time you're thinking about your tests, give JSDOM a try. You will not regret it. Thank you very much.